Hi, my name is Aaron, and these are 3 things that you need to know about passive cooling. Number 1, most important, is heat avoidance. The best way to cool your building is to not have to cool it at all. Window exposure, we want to think about shading windows from the hot summer sun in the northern hemisphere. High R-value walls, we want to be able to keep the outside out and the inside in. We want to make sure that our building is oriented appropriately so we're not getting hammered by the summer sun when we don't want that extra heat. Number 2, stack effect. What is it and why do we care? The stack effect is a principle where in an enclosed space, warm air is going to rise to the top and cooler air is going to fall to the bottom. And why is it important in building? If we can exhaust warm air out of the buildings and draw cooler air into the buildings, naturally that's going to cool the space. The greater the height difference, the more stratified that air is going to become. The warmer air is really going to collect at the top and the cooler air is going to fall to the bottom. We see this used to great effect in something called a solar chimney. A solar chimney is essentially a chimney that's going to allow that warm air to exhaust out the highest portion of the buildings, and naturally that's going to create a negative pressure within the building, and the building is going to draw cooler air down towards the bottom of those spaces. So first, the anatomy of a solar chimney. Of course, on the southern facade we've got as much glazing as possible so we can access as much solar gain as possible and internally heat as much air as we can. Above my head here we have the most important part of a solar chimney, the louvers. The louvers control airflow. The internal temperature sensors sense when the air inside is warm enough, and they'll actuate those louvers and tilt them, allowing the inside air to exhaust out the solar chimney. So right away I can tell you I have 2 questions. First, why is this donkey wearing sunglasses inside? Well, I broke my nose and I'm sparing you having to look at me looking like a raccoon. Number 2, how does air move between the 2 floors and exhaust out the ceiling? The answer is this. A ventilation shaft. So between floor 1 and floor 2, there are louvers actuated by the same temperature sensors. And between the floor 2 and the roof, there are the same louvers actuated by the temperature sensors. And I'll show you what those look like right now. But if I can put my hand out here, I can actually feel air moving all the way from the bottom floor, all the way up and out the roof. Number 3, creating a pressure and temperature difference within our spaces. And that's going to allow us to use that stack effect really effectively. We can also use things like prevailing winds. If you know that you always get a breeze from east to west or north to south, in the summertime, you can optimize the building and optimize the operable windows within that building to be able to take advantage of those breezes. We can use things like wind scoops. We see those in really hot climates. Basically, a big baseball mitt that catches and funnels air into a building. And sometimes they use water features, pools, fountains, even jugs of water to help cool that incoming air as it moves through the space. So one application for these strategies is to create our own stack effect. If you live in just a regular 2-story house, in the summertime you can open one window high on one side of the building and open one window low on the other side of the building, and see if you can create that stack effect up through that stairwell, provided that your stairwell is open and not closed. I don't do any social media marketing, so if you've enjoyed this content, please pass it along to someone you think might enjoy it too. And if you want to work with me or submit a question for my FAQ videos, please visit albatrossdesigndraft.com. Be well.